Okay. So, I would like to start by saying a few thoughts regarding the front-end ecosystem in general. Over time, we see that framework authors are slowly adopting ideas they once avoided, and they find even more common ground as time goes. For example, we see that server-side rendering has been a big emphasis over the past years. We also see that everyone nowadays agrees that component-based architecture is the way to go, and that templating now belongs to the past. At the same time, many agree that web components are tough to use, and you need a very compelling reason to choose them over regular frameworks. And let's not forget that frameworks are slowly adopting ideas they once avoided, like React 19, for example, introduces a new compiler that reduces the need for manual optimization. You don't need to use your mem or use callback anymore. Svelte 5 is also introducing signal to reactivity. And Angular is introducing a new amazing feature, which is called partial hydration. But one could argue that it shares some ideas from Wix usability. Although, to spoil it here a bit, it doesn't, it actually shares some ideas from the Wix framework, which is internally used in Google. But the point is that frameworks are slowly solidifying certain approaches that and concepts, and this is especially true when it comes to signals. Angular in particular has always been keen about making reactive and performant applications. Even more so now with signals. But signals aren't just a minor enhancement over Angular's reactivity. They change the way we think reactivity in Angular application. They do this by removing unnecessary complexity, making dependencies optional, and they do this all while making our developer experience better and also our applications more intuitive to manage. And to see how transformative signals can be, consider that one of the most complex applications on there, YouTube, utilizes Angular signals fully. So how does a complex app like YouTube harness the power of signals? How does it decide when and where to use them effectively? And especially when dealing with asynchronous operations. That's what brings us to today's talk. We'll dive into challenges signals face with asynchronous tasks, the innovative community solution, and the official tools that Angular provides us to deal with them efficiently. By the end, hopefully you have a toolkit to work with signals and asynchronous operations more gracefully. But let's first understand how signals work exactly. By definition, it allows the framework to optimize rendering updates by granularly tracking the state. But what does granularly really mean here, or more commonly known as fine-grained reactivity? And to understand what granularly means, we have first to look a bit how change selection currently works out in Angular. So by default, Angular utilizes Zone.js, which is a library that intercepts asynchronous operations, like HTTP calls, timeouts, UI events. And it basically tells Angular that a change has occurred, but it doesn't really pinpoint where this happened. So by default, Angular has to recite to a change selection mechanism called dirty checking, which basically means that you have to check the whole component tree just to find where this change has occurred. Which of course in larger applications it can hit the performance dramatically. So to compensate with that, Angular provides us on push as well, which is a change detection mechanism that basically checks only data-bound input properties, and when you actually trigger change section manually, like an example here. This can significantly improve performance, especially in large applications, and it reduces the cycle and the scope of the change section cycle. And we give us also more control over what is being rendered and when. However, this is also now a drawback because you as a programmer have to know when to synchronize the state with the UI. So now with the integration of signals, Angular change section becomes even more efficient, targeting updates with precision. Change section now is scoped directly to the components affected by the changes, and this means that when a signal is changing, Angular is equipped to know the exact location of the UI that needs synchronization. And okay, still the change section happens at the component level. However, Angular optimizes this process to update all the necessary parts of the DOM. So in other words, we granularly update the parts of the DOM that has changed, which of course can improve performance even more. However, it also opens the door for a zoneless future, because now Angular knows by itself what to update and when. So let's look at a minimal example of how signals work in action here. Using three signals, first name, last name, and full name. If you want to access the value of your signal, all you need to do is to call it like you would do with a regular function. If you want to set your signal to any value, you use the .set method, and then anytime you try to access your signal, you will retrieve the updated value. For the computed, Angular will create a dependency connection between the computed and any dependencies read inside the signal. When one of these dependencies changes, it will trigger the computed to run again. What is really important here is that the computed is lazily executed, which means that the updates will happen when I'm trying to access the computed itself. Another thing here is that the effect acts as a reactive watcher here, which means that we still track the dependencies inside here, and each time that one of those update, it will trigger the effect to run. Also important note here, the effect, it is scheduled by the framework when it's going to be run. This is really important because it's an asynchronous operation. So in the very first run, the effect gets scheduled and runs, and then our first name signal is set to John, and three things are happening. So Signals provides us simplicity, readability, ease of use, and most importantly, direct dependency tracking. But how can we leverage all these benefits for asynchronous operations? There are a couple of ways we can use Signals for that, but not all of them are recommended. So now we see a small demo of an app and try to replicate it with different approaches, and try to explain why some of them are preferable and some of them are not. So our goal is to implement a small asynchronous feature, which is fetching the astronomy picture of the day from an NASA endpoint, based on a provided date. When the date changes, we want to trigger a refit. And we also want to cancel any ongoing HTTP calls. So we want the functionality we have with a regular switch mode, basically. So first we have a more traditional RxJS-focused approach here. We utilize a subject and a switch mode to make and cancel any ongoing HTTP calls. The benefits of this approach is, first of all, we utilize the RxJS operators, which are very powerful. But most importantly, the key benefit here is that we have a unidirectional state pattern by setting our state at the end of our synchronous flow. This means that we have a single state of truth that remains always immutable. And then we leverage the power of Signals to do the heavy lifting for us, which is to synchronize the states for us. We also have to mention here that we have a small drawback. And the drawback is that we actually have to subscribe, which means that we have to break our declarative paradigm here. And we have to imperatively set our data, and we also have to handle the subscription. And we could use maybe a signals-only approach here. Here you may notice that we use the date signal, which triggers the effect itself. Then inside the effect, once we receive our data, we simply set it again to our picture of the date. You may also notice here that I have to explicitly pass a flag that allows Angular to set the signal within the effect. And usually, setting a signal within the effect can sometimes be a bit questionable. And the reason is that it can lead to some issues. Some of them, for example, is like an infinite loop. Or maybe some glitches that we're going to explain later on how they can occur. And in many cases, it's worth revisiting the example to see if there's a different approach we can take for our problem. And what happens if you cannot avoid this? What happens if you have to set a signal within your effect? This is why Angular team also provides us with the untracked API, which basically means that anything that runs inside the callback here will be not registered as a dependency by Angular. And here you'll notice that while the untracked API makes our code a bit more readable, because also we have more dependency control over what is happening here in the effect, we miss the functionality we had before with the switch map. We do not cancel the ongoing HTTP calls. So maybe we can recite to third-party tools to bridge this gap for us and have the same functionality we had earlier. So with that, we can utilize the NC extension library, and more specifically, the delete async. which effectively bridges this gap because it combines the benefits of both. It does this by allowing us to set certain behaviors that correspond to HTTP calls. So I can set concat for concat map, merge for merge map, switch for switch map, etc. If I do not pass anything to the direct async, it will basically try to make the call like it would do with a regular switch map. You also notice here that it actually provides us back a signal. So how does direct async provide us back a signal while also using the RxJS operators and also avoiding the pitfalls we mentioned earlier? Well, if you check the actual source code here, you will see that it actually shares, it uses an effect to synchronize the state with the asynchronous calls we are making, the synchronous operations. You may also notice that it actually assets an injector because the effect has to run inside the injection context. And we will also notice that it actually uses the attract to avoid what we said earlier. And this is to avoid making the infinite loop. What is really interesting here, in my opinion, is that it also utilizes a subject. And this is for two reasons, actually. The first one is to pipe into the RxJS operator that it wants to, based on what the user gives it. But it's also not to use any events. And this is critical because although signals are always up to date, they can feel like they are batching events. They're actually not. They are not. What we have to keep in mind is that they are not streams. They are a different mechanism. And if you want to propagate every single event to the system, it will be better if you actually use the subject instead. And the reason they do this is to ensure that you have a glitch-free synchronization with the UI. But now with Angular 19, we can also use some native solutions. And this is the resource API, more specifically, which is still experimental, but it's very promising. And with this approach, we can pass an object containing a loader, which holds which will be run inside the effect.again. And here you will see that while the initial call will happen, and I will see my data, if I try to pick anything else, nothing happens. And this is expected here because we have to provide another property, and this is the request property, which tells the resource object to respond to JSONs to changes from the provided signal. And another great thing here is that it actually has the switch map-like behavior we had before out of the box for us. It will use an onboard signal underneath, and it will try to cancel any ongoing HTTP calls. So now we have the same functionality we had earlier, but most importantly, we have this natively. We don't have to import anything, not even RxJS. But the resource object also gives us more stuff. We can also get access to the error, to its loading signals, status, value, all of these that are very useful if you want to show intermediate states to the user. And for those familiar with TANStack, this API is quite similar with TANStack Query. And I mention this because Angular team is quite aware of the similarity, and this shows that they actually are not enclosed within the ecosystem only. They try to see what is the best from the framework and try to bring fresh ideas to the table, basically. But let's try to expand a bit our application here by adding a gallery for favorite days. With this feature, you can save specific days to your local storage and later view them, along with the description without needing to fetch them again. However, there's a minor issue we have to address here. When I select a picture from my selected gallery, and I want to try to fetch a new one, you'll see that nothing happens actually. I'm not fetching anything. And the reason is that I'm actually trying to prioritize the selected picture signal to show, and then fall back to the one I'm trying to fetch. So maybe a solution we could use here is to try to reset the selected picture so we can have the right fallback. So in other words, I want to When I update my date signal, fallback, remove the selected one and make it undefined. So one intuitive maybe solution it will be to try actually and do this inside the leaflet. So here I'm basically trying to react to updates of the date signal to set the selected to undefined. So this is an approach that most of us would do trying to solve this issue. And while this is working here, it could potentially introduce some glitches. And this is due to the slight delay between the two operations. Like I mentioned earlier, the effect is scheduled by the framework when it's going to be run. This means that these two operations have some time buffer inside, which means that we have an intermediate state that we may show to the user. Additionally, there is a design flaw here. We are observing a signal to react to another one. We should basically try to link them together, in a sense. We want to not coexist without the other. So maybe instead of taking this approach, we could shift our perspective and initialize a completely new signal directly when we receive a new value. So this way we eliminate the need for resetting and we ensure that the signal is updating reactively. And then, of course, if I want to access my signal again, I have to use the state and then call my actual signal. But you could also additionally use a new API, which is introduced in Angular 19, which is the linked signal. It's still of course experimental, but it's a really nice solution to our problem. Here we can pass a source signal which indicates that each time a resource is getting a new value, we will try to run the computation here. So I'm essentially now resetting the state of my selected picture each time I'm receiving an update. So let's summarize a bit what we talked about today. Use signals, in my opinion, if it alleviates complexity. Use signals if it's synchronized to synchronize the UI state. And avoid signals if you need all the events to be eagerly propagated to the system. And do not use signals for very complex applications, for very complex asynchronous operations, sorry, at least not yet. And use effects to synchronize the state with asynchronous operations like HTTP calls, etc. And do not use effects to synchronize the state with signals, and try to question implementations that set the signal. And the two main ones, in my opinion, keep in mind that signals updates are lazy evaluated, and when you're trying to access signals, you always get the latest value. And that the effect it is scheduled to run by the framework. And for more information, you can also visit my blog about this.